Well, I am getting closer to building the wheels for this 8-passenger Yellowstone Park Stagecoach. But you remember when I did the shoulders on these spokes, they are a 90-degree shoulder. Well, I'm putting them into a cylindrical hub. So if I just set them in, that full shoulder doesn't make contact with the hub. So I just take a file and I put a little shoulder on each side of those mortises, so I have a flat surface in the cylinder for those shoulders to come in and make contact. Well, last week, as I was working through the process of trying to explain dish in a wheel and why it's there and how you do it, as I was putting that video together, I was kind of wondering if this was TMI, too much information. Some of you probably are not interested in all these little details. I don't know. But, part of the purpose of going through all this is to address the mystery of wheel building. It is thought to be kind of this mysterious, magical type of deal. And it is really just basic woodworking. Well, maybe I shouldn't say basic woodworking. It is woodworking, just taking it into the arena of circles. And I think as I try to go through this piece by piece, some of the mystery disappears, and you can see it just kind of makes sense. So I have my first set of spokes cut out and all the shoulders adjusted, remember, to that 1 degree and 1.5 degree. And these are the 1.5s. But there's an adjustment on the tenon that probably many of you picked up on, that when I adjusted that 1 degree shoulder, it affects the tenon on that spoke as well, because the mortise in the hub remains straight. So how do I have an angled shoulder and a straight mortise? So I'd like to touch on that. So I have a piece of paper that I taped to my planer table, and I have it squared off with both edges. So if I were to simulate a mortise in my hub, that would be somewhat in this area. And then this would become the face of my hub, and I want my spoke to set into this mortise. Now remember, if I just put that in straight, this would be the outside of the wheel, this would be the dish side, and then this back side is tapered. So I had to adjust the angle of this shoulder in order to lean this spoke forward this direction to create my dish. So in essence, what I did was lean my spoke forward, but in order to get that to accomplish, I needed to adjust this square angle of this shoulder. This is somewhat exaggerated, but like so, in order to lean this forward. And when this leaned forward, this comes down and sets up against the face of the hub. Well, what happens is this leading edge of my spoke now doesn't set straight or doesn't come up flush against this mortise in my hub. so I could have contact here and end up with a space here in the inside portion of my mortise as this spoke leans forward. So how do I adjust that? I actually need to take and put just a little bit of a stair step into this tenon that will allow this to set up tight against this square portion of the mortise. So when I change the angle of this shoulder, my leading edge is no longer square, it's a degree off. So what I'm in essence doing is I am re-squaring up the face of the tenon with the angle of my shoulders. So that's, again, this is somewhat exaggerated, but this is what I need to do. I need to keep this corner here at a 90 degrees, this corner here. So sometimes this stands out a little more clear if you exaggerate things. And that's kind of what happens when you get into building Civil War cannon wheels. I have a spoke here that is made for these type of cannon wheels. And it is an exaggerated case because wheels for a cannon have to have an exaggerated dish. Remember that cone where I put that quart of paint on top of it? Well, the same thing is exaggerated in a cannon wheel, because when you have the weight of the cannon barrel and you are in the heat of battle and you're turning and making, really fast maneuvers, the weight of that cannon is an extreme force against that hub, so they increase the dish on those cannon wheels to withstand that force, and the spokes are made accordingly. As we look down the leading face of this spoke, you can see this extreme change in the angle of this tenon. This shoulder here to this shoulder here is actually square. But when this sets up against the hub, it goes into a square mortise, but this spoke has an extreme dish. This is probably closer to 4 degrees as opposed to the 1 degree that I'm putting in this Stagecoach wheel. But that's the effect that we have to accomplish in these Stagecoach spokes, or any wagon spoke. And when you're dealing with just this 1 degree in wagon wheels, it is not uncommon that it would be just forced in without making this adjustment on the leading edge of this tenon. And the force of the tire would actually compress this wood into that. I've taken apart thousands of wheels, and oftentimes you will find this little indented portion right here at this joint. Well, that is what has happened. As that tire has set and pushed this shoulder down square against the hub face, this has to compress, and it works. When you get into building cannon wheels, you can't force that much compression. So then you have to actually do the physical adjustment. On the case of these Stagecoach wheels, I'm just going to take a file and just take off that fuzz, whatever that fuzz is, and make that a little bit of an adjustment, because we're just talking 1/16 of an inch on the length of that tenon. There's only going to be about 1 3/4 inches long. So I just take a little file and I step that in a little bit. It helps that sit more square against that mortise, allows that shoulder to come up straight. And then I've also got to make a little adjustment on the back side of that tenon. So as I mentioned before, this leading edge of the mortise is straight. It's 90 degrees to the hub. And the back side, I do put a taper in, and from the leading edge or the face of the hub to the inside, generally I'll put about 1/8 of an inch taper. So the front will be square, 90 degrees, and then a taper here. The degree isn't really a big deal, but what I'm trying to do is add a wedge to the end of the tenon. And what the goal is to have this shoulder seat up against the face of the hub at the same time this wedge comes in and seats up. All this is to prevent that spoke from driving too far in, making contact with that boxing, that cast iron sleeve that goes inside, and breaking that. So these shoulders do have an effect of making that stop. You know, if this was the spoke on the side view, and you know, they have a shoulder like so, these little shoulders do help stop that. But when you put this wedge on the back side, that is more of a positive stop, and it helps from breaking these little shoulders or the spokes off. So you want this contact on the shoulders and this contact in the wedge to both make contact at the same time. So when I do a little adjustment like this, when I'm putting them onto a wagon hub that have bands up against the spoke, this little shoulder is not noticeable at all. But on these Stagecoach wheels, there is no band up against the spokes, so it's pretty easy just to take and kind of make that disappear. It's just a slight little slope, and it's actually kind of like the Civil War wagon wheels, where it just makes that little gradual turn. So just take and kind of make that disappear. So I'm going to do all the upper spokes, which I call the leading spokes, and just find the thickness of the inside of that taper. It has about that 1/8 of an inch difference from the inside to the hub side. Transfer that to my tenon. That'll be my taper. This may seem like a lot of detail, and it is, but if you're interested in more of the wheelwright stuff, I have different playlists that are regarding wagon wheels, buggy wheels, carriage wheels, cannon wheels, American cannon wheels, French, Spanish cannon wheels, 1,000-pound wheels like the borax wheels, in a lot more detail than what these last couple of videos have been. But the principles are the same. So if you're interested, it's all there. So this is the first of 7 for my leading spokes, and then I'll put in my secondary spokes that actually adds that strengthening triangle effect to these offset Stagecoach wheels. So the goal of this is to have 2 layers of spokes coming out at 2 different angles, come out relatively close to where the rim is going to be, where the tire sits. Now this isn't going to be 100% exact because we're not working with injected and molded plastic. We're working with wood, and wood is alive and it's always different. But generally I would like to spin these past the constant point, and I see my brake block on this undercarriage is there relatively close. And as I run these by, they're pretty close. There's one that's maybe a little low. You know, those little variations might be, 1/8 of an inch. But that's not something that I get too excited about. When I put these 2-inch rims on here and eventually set the tire on, I'm going to drill the holes for the tenons on the end of these spokes right in the center of that felly where they need to be. So that felly is actually going to take these little variations out and put them exactly where they need to be. Set the tire, everything's directly in line. Now the final fine-tuning actually happens after that tire is set, and I've done this in other videos where I have a hub boring machine that I put the whole wheel on, then I bore the center hole for the bearing called the boxing that goes on the axle spindles, and that's what actually makes this wheel run dead on center. So these little variations here, we're pretty close. So let's double check and see if my dish is close. If I take a board and set it across the tip of 2 spokes that are on my leading spokes, and if we look down in this area here, it looks like we're in that 1/4 to 3/8 of an inch area. Let me try another spot. Kind of right in there. So we're pretty close on the dish that we want. I really would like these to be a bit on the shy side. So when I put the fellies on and I do that final circumference measuring to coordinate with the dish in the length of the spokes, then I set that tire. Remember, I put it on my wheel stand to shrink that. And I like to be able to put a little pressure on that hub to bring just a little bit more dish into it. If I have too much dish, it's a little more difficult to take out. But new wheels, it's pretty workable. But I think we're right in that ballpark where I think it's going to work. I just have to do 3 more wheels. Anyway, appreciate you coming along. Hope this all makes sense. Thanks for watching.